Hi everybody, so we're just reviewing the second part of the respiratory physiology laboratory here. So this part of the lab focuses on the concept of a nomogram or a nomograph. It's the same thing. A nomogram or a nomograph is a useful clinical tool where we calculate one useful clinical value based on two other values that you're able to figure out by directly observing, measuring your patient. So in this case, what we're going to do is that's not supposed to happen. Let's get rid of that. So what we're going to do is we are going to estimate a person's surface area. In this case, I'm going to be the guinea pig. We're going to estimate the surface area of my body using my height and my weight. So this is the first nomogram, by the way, that we're going to use in order to calculate the surface area of my body. And then we're going to multiply that surface area by a gender factor. So the gender factor is going to allow us to convert the number that is the surface area of my body to my estimated forced vital capacity. And the forced vital capacity is the exact same thing as the vital capacity. And if you've already watched the video on the respiratory volumes and respiratory capacities, then you'll know what I mean. If you haven't already watched that video, then I recommend that you watch that video first. So that's the first video that I have listed within the videos folder within the respiratory physiology folder. So again, the big picture here is we're using a nomogram to find my estimated surface area of my body, and then we're going to multiply the estimated surface area of my body times a gender factor. The gender factor is just a number based on whether you're a male or a female, because whether you're a male or a female is going to have a significant predictive value as far as what your forced vital capacity may be, what your estimated forced vital capacity is. So then I'm going to multiply my surface area by that gender factor, and then multiply that by 1,000, the whole number that we get from multiplying those two variables, and then that is going to give me my estimated forced vital capacity. Does that make sense to everybody? And then we're going to go further and use a slightly different means of estimating my forced vital capacity. Instead, we're going to use two different charts, and then we'll average those two different values together, the value that we got from the nomograms and the value we got from the charts, and we'll come to a good estimate of what my forced vital capacity may be. Now remember, when I did the respiratory volumes lecture video, we talked about pulmonary function tests. So pulmonary function tests are tests where you go to the hospital and the respiratory therapist asks you to inhale and exhale through a tube that's hooked up to a spirometer. And the spirometer, by using the rates of air passing through the tube, is able to extrapolate what your certain respiratory volumes and respiratory capacities are based on what the respiratory therapist is asking you to do. So we can directly measure most of that information, or a better way to say it would be that we can directly gather most of that information through pulmonary function tests. But if you don't have pulmonary function tests, then we can estimate it based on these two means that we're going over right now, the nomogram method and then using those two charts that I just showed you. All right. In addition, when you actually do measure the vital capacity or forced vital capacity of your patient in a pulmonary function test setting, you also want to figure out, well, is this value normal? If not, how different from the normal value is it? Well, in order to calculate what the normal value may be for that particular patient, then you're going to have to resort to one of these methods that we're doing. Now, usually what happens is the computer already has an algorithm built into it where the information that we're going over here, like weight and height, is already plugged in based on the patient, and the computer figures out what the estimated forced vital capacity or what any number of different estimated pulmonary volumes or capacities may be. But this is the more old-fashioned way of doing it, but still it's important that you understand the basis of how these estimates are actually arrived at. So again, going back to what we're doing right here with the nomogram, what I'm going to do is I'm going to get out a straight edge, which I had right next to me just a few moments ago. me see where it is. I don't know where it is. Don't you hate that when you put something aside, knew where it was, and you're so proud of yourself for keeping things organized ahead of time, and then right at the last minute, you just flat out lose it. All right, so I'm just going to improvise here and just use a box. Okay. Oh, here it is. All right. So over here on the left column of the nomogram, I'm going to make a little notch for my height. So we'll go back to the pen tool right here. So I am 6'1" inches. So if you're 6'1", then that correlates with a height of about 185 centimeters. So here's my height right here. I'm going to make a little notch mark there. Everybody see this little? I'll put an X through it so it's more obvious. And then we're going to go over to the column on the right, and I'm going to put in my weight. So my weight in pounds is 165, corresponds to about 75 kilograms, and I'll put another X through that. Now what we're going to do is we're going to take a straight edge, and we're going to draw a straight line through both of these marks, and the straight line is then going to intersect across the column in the middle. And where it does intersect, that's going to be my estimated surface area of my body in terms of meters squared. So here it is. Let's just say it's 2.0. I know it's not exactly 2.0, but let's just say it's 2.0 meters squared. So that's the estimated surface area of my body. So now what we're going to do is we are going to go back here and insert our values. So I said that my estimated surface area is going to be 2 meters squared. The gender factor we're going to use, we got to go back up here and see the gender factor for males is 2 liters per meter squared, and the gender factor for females is 2. Or did I say 2 for males? So for males, the gender factor is 2.5 liters per meter square, and then for females, it's 2.0 liters per meter square. So I'm a male, so I'm going to put down the number 2.5 liters per meter square. And when you multiply these two numbers together, the metered square crosses out. And so when you multiply 2 times 2.5 liters, you get how many liters? You get 5 liters. Now to convert this to milliliters, because we want to find our estimated forced vital capacity in terms of milliliters, you're going to multiply that number by 1,000. So you're going to multiply 5 liters times 1,000 to get the equivalent number of milliliters, which is 5,000, right? So we got a total of 5,000 milliliters is my estimated forced vital capacity using the nomogram method. All right, so the second method here is we are going to determine my vital capacity or forced vital capacity based on my age. So we're going to go to one of these charts here and see there's a chart for males and there's a chart for females. So we're going to focus on the chart for males, and I'm going to select my age. And by the way, it's not just age, but it's also height that we use for this particular method of estimating forced vital capacity. So my age is now 38, and my height, we just said in terms of centimeters, is going to be 185. Now the problem is that this particular chart is only an even number, so there's a 184 and a 186. My height is going to be right here. So I'll show you what we're going to do with this in just a moment. But first what we're going to do is we are going to draw a line across this chart, actually 2 lines. So we're going to underline the row that corresponds with my age, like so. And I'm going to attempt to do this again with my straight edge. I don't know if it's going to work. I'm doing this on an iPad, by the way, so the surface is very slippery. All right, look at that. Okay, so now what we're going to do is I'm going to draw some vertical lines now associated with where my height was marked off. Oh, I messed it up. So let's go back here. I'm going to draw some horizontal lines associated with where my height was marked off. Maybe I won't use the straight edge. I think the problem is getting confused with the straight edge. The touch screen, that is. Okay, so I'm going to draw some vertical lines associated with my height. So now, instead of having just one number here that would be associated with my height and my age, if I had selected just one column for my height, like let's say I was 184 instead of 185, well, I would just select this column right here. And so the number on the chart that would intersect with both this column and my age would be this number 4305. But it gets a little more complex if your height is an odd number and it falls between the two columns. So instead, we have two numbers. We have 4305, and then we have the number associated with a height of 186. So this number is 4350. So what we're going to do is we're just going to average those two numbers together. So I have my calculator out right here. So 4305 plus 4350 equals 8,655, and then divide that by 2 to take the average. And so the average number here is 4,327.5. So that is going to be the value for my forced vital capacity using this method. So that's quite a ways off from the first method, which estimated my forced vital capacity at 5,000 milliliters. Now it's 4,327.5 milliliters. So in order to find the best estimate of my forced vital capacity, we're going to take the results from both of these methods. Let's see where this is, going back to the, by the way, this is where we put that number. So yeah, 4327.5. So now what we're going to do is we're going to take the first estimate, which is 5,000 milliliters, plus 4,327.5 milliliters, and divide them by 2 to take the average. So get out my calculator. 5,000 plus 4327.5 divided by 2 equals, oh wait a second, that can't be right. 5,000 plus 4327.5 and then divided by 2. So the final number here, the best estimate using both of these methods and then averaging the results, is 4,663.75 milliliters. All right. So when we talk about differences between these numbers and the normal numbers, the simplest answer is that these are very, very crude estimates. There's a lot of different shapes and sizes of human bodies, and they don't always directly correlate to a person's height, weight, age, or sex. So because of this diversity we have in our morphologies, using these very crude parameters to be able to make estimates is not necessarily very reliable. So that's the big picture take home here. You don't have to really analyze it any further than that, or at least that's not what we're looking for. All right, we just want you to be able to see the forest through the trees on this one and understand that whenever you're making estimates based on only a few parameters, those estimates are always going to lack precision. All right, so anyways, the last part here, minute respiratory volume, I do go over the minute respiratory volume on that first video that I posted on the respiratory volumes and respiratory capacities. So this is very simple. You just take your respiratory rate. Let's say my respiratory rate is 16. And by the way, you guys know how you measure someone's respiratory rate, usually what you do is you take their pulse for 60 seconds. For the first 30 seconds, you actually are taking their pulse, and then you just multiply that number by 2 to get their estimated pulse. And that is their heart rate, right? And then for the second 30 seconds, while you're pretending to still take their pulse to calculate their heart rate, you're watching their chest. So you're seeing how many times their rib cage elevates or depresses within that 30 seconds, and then just take that number and multiply it by 2. So let's say mine is 16. Tidal volume, my tidal volume is probably at least 500 milliliters. That's a normal tidal volume. Tidal volume, by the way, again, is just the normal amount of air that you inhale or exhale with normal breathing. So when you multiply that tidal volume times the respiratory rate, that's going to give you your minute respiratory volume, which is really just the amount of air you either take in or exhale. A better way to say it, more precise way, the amount of air that you either inhale or exhale within 1 minute. You got to choose which one, but they're both going to be the same because you're always going to be inhaling and exhaling the same amount of air. So in this case, 16 times 500 is going to be 8,000 milliliters per minute is my estimated MRV. All right, everybody, so that's it. And then the next tutorial coming up is the John Smokestack case study. All right, I'll see you soon.